Hello students, today we are going to take up the basic fundamentals in inorganic chemistry, the trends in a period and groups about the physical properties like atomic size, ionization energy, electron affinity, electronegativity. Let us start with a very good thought: patience, persistence and perspiration, an unbeatable combination for success. These three P's, when you apply in your life will become successful. So the learning outcomes: atomic, you will be able to know about atomic and ionic and van der Waals radius, ionization energy, electron affinity, electronegativity, trends in periods and groups about the physical properties. So first thing, basic thing we should be knowing about the chemistry, the branches of chemistry. Chemistry is a natural science that falls under physical science and based on observation and experimentation. And basically the branches are organic, which deals with hydrocarbons; inorganic, which deal with inorganic compounds; biochemistry, deal with the biological aspects of the chemistry; physical, that related with the structure, the properties, the thermodynamics; the analytical, the finding, the identification and conformation of a particular cation or anion. So the main branches here we have discussed already. Now we are moving towards the basic thing which we have in the last video we have seen about the electronic configuration. Just put more details over it. So electronic configuration means the distribution of electrons by filling of atomic orbitals as per their energy levels. Lesser energy will be filled first and higher energy will be filled later. So basically four types of orbitals: SPDF, accordingly SPDF block are there. So S can have maximum of 2 electron, because any orbital can have maximum of 2 electron. P are having 3 different orientation: Px, Py, Pz. So therefore one can be accommodated in each P orbital, so total numbers will be 6. Similarly D are having 5 D orbitals, 5 different types: Dx, Y, Yz, Zx, x square, y square, z square, and have maximum of 10 electrons, because each orbital can have maximum of 2 electrons. Similarly F orbital can have maximum of 7. So you need not to remember these type of orbitals. And 7 into 2, 14. So there are 14 electrons can be accommodated in the F orbitals. Therefore 14 elements are there in the F block, or lanthanides and actinides. 14 elements are there. And D, D block, there are 10 elements in each row. So as we discussed last time also, this is the energy level. We should be careful while filling the energy. Lower energy will be filled first, followed by higher energy levels. So similarly, basically we have to start with the P block elements, which constitute group 13 to 18, and 13, 14 was the part of +1, and 15, 16, 17, 18, these 4 groups are the part of the grade 12 examinations of chemistry. Okay, so now these are the basic group 15 elements. How to write the electronic configuration, you should practice at least. We should be aware of the atomic numbers of group 15: nitrogen, phosphorus, arsenic, antimony, bismuth. And similarly electronic configuration we can write, and group number is 15, period number is 2nd, 3rd, 4th, 5th, 6th. Okay, similarly oxygen, sulfur, selenium, tellurium, polonium, and electronic configuration we should be aware of along with atomic numbers and symbols: fluorine, chlorine, bromine, iodine, acetine. So therefore we are aware now about the group number, period number, electronic configurations, and group 18 also: helium, and argon, krypton, xenon, radon. So one important question arises: how to remember the atomic numbers of all the elements if atomic number is not given. Normally it is given usually, but if not, then how you can find out? That's very easy. So you must be aware of the first period only 2 elements are there. Second and third period you might be aware of. Even though if you are aware of the period number 2, then you can find out the elements in the next period in a group. Like for example, if I am talking of group 13, elements are boron, aluminium, gallium, indium, thallium. Similarly carbon 14 group, carbon family: carbon, silicon, germanium, tin, lead. Similarly 15, nitrogen, phosphorus, arsenic, antimony, bismuth. 16, oxygen, sulfur, selenium, tellurium, polonium. Similarly group 17, fluorine, chlorine, bromine, iodine, acetine. 18, neon, argon, krypton, xenon, radon. So if you are aware of boron, carbon, nitrogen, oxygen, fluorine, neon, what you have to do is you have to add 8 in the atomic number. 8 plus 5, 13. Similarly, carbon 6 plus 8, 14. 7 plus 8, 15. 8 plus 8, 16. 9 plus 8, 17. 10 plus 8, 18. So this way we can find out the atomic number of period 3rd. If period 4 we need to know, then we have to add 18. Similarly, if you want to know about the next period element, you have to again further add 18. If you want to know the next element, then you have to add 32, then again 32. So it means these are the magic numbers. Which magic numbers? 8, 18, 18, 32, 32. These are the magic numbers, which is thereby the elements are having same outer electronic configuration, which are responsible for the same physical and chemical properties. Okay, physical properties might vary a little bit, but chemical properties are same due to the similar outer electronic configuration. Now, so if you are talking of the next part, so these are the elements we are aware of already. We know about the periods, we know about the groups, we know about the alkali metals. Group 1 S block, alkaline earth metals, that is S block. Group 2, similarly 17 halogen, that comes under P block, and 18 also noble gas comes under P block. Now the point, the concept, the atomic, metallic and ionic. What is the difference? Atom, metal. So let us talk about the metal. Metal, you know that metallic type of bonding is there, where positive charge kernels are bonded with the negative charge electrons through metallic bond. So here Na and Na, they are combined together through metallic bonding, and the sender, from the sender or from the center of the two nuclei divided by 2, this is radius of metallic, radius of sodium, let us say. Similarly, if chlorine is the molecule Cl2, there would be, this is a non-polar covalent bond, there would be sharing, there would be overlapping of atomic orbitals. So the center to center distance divided by 2 will be giving the covalent radius. And similarly, if there is ionic bond, you know cation is smaller than anion, so Na plus is smaller, Cl negative is larger. The center distance between the two ion, cation and anion, divided by 2, that will give the ionic radius. Similarly, if you see this portion, here you see down what is happening? The atomic size is increasing. And if you see this 60 and 152, what is the meaning to that is, this would be the ionic, this is the atomic size. So ionic size is always smaller than atomic size. And you know that basically down the group atomic size and ionic size increases, and if you go in a period, the atomic size and ionic size decreases. Okay, see here, nitrogen is 171, 140, 136. Similarly down 140, 184, 198, 221. So that is down, it is increasing, and from left to right it is decreasing. Now let us talk about the van der Waals radius. In van der Waals radius, you know that van der Waals basically operates in gases where there is no overlapping. Only the molecules are closer, that's all. So if I am talking of one van der Waals molecule like helium. So helium, the center of the nucleus to the outermost shell, that gives us the van der Waals radius, and van der Waals radius will be the maximum as compared to atomic, ionic or metallic radius. Okay, so it is the half of the shortest internuclear distance between two similar non-bonded atoms. There is no bonding, so center to center nucleus, the distance divided by 2, so that will comes to the van der Waals radius. Now size depends on so many factors like shells, number of shells are increasing, size will increase, and if you talk of high nuclear charges there, then also size will increase, size will decrease because the force is more. And but here one more concept which you might be feeling a little bit difficulty, always we should keep in mind, this is screening effect. Screening effect means what? Screening effect is a shield. For example, positive charge inside the nucleus, positive charge is there due to protons, and outside electrons are there, this positive charge is attracting the electrons. Now if you provide the shield in between means in between the nucleus and the outermost electrons, if shield is there, the force of attraction will be relatively less. If a force of relatively less, then we are saying that this shield has decreased the force of attraction, or there would be change in the atomic size. So somewhere shield is good and somewhere shield is poor. In case when there is 3D orbitals or 4D orbitals or 5D or 4F, these are having imperfect shielding. It means they are not shielding it properly. So if shielding is not properly, the relative nuclear charge is increasing. So thereby size will decrease drastically in some cases. So where the effect of shielding is poor. Okay. So always keep in mind about this concept more will be used in the D transition elements. Okay. Next is trends of atomic radius, down the group trend. As you can see from the cesium is having higher atomic size as compared to rubidium, potassium. So down the group atomic size increases. Along the period from left to right it decreases. So this we should keep in mind. So always, and you know that if you talk of alkali metal will be having the highest atomic size in a period, and in a group, you know, down the group atomic size increases. Okay. Next is trends. We have discussed already. Atomic size decreases in a period and atomic size increases in a group. Period decreases because relative nuclear charge is increasing, and atomic size increases down the group because of addition of new shell. Force of attraction between the protons and protons and electrons decreases. Now let us understand about, you can pause the video and check the answer, that will be more better. So these are the final answers. So potassium, you know the potassium is below, down the group atomic size increases. Potassium and magnesium, if you see in a period left hand side potassium is there, so high atomic size. Similarly potassium and potassium ion, because cation is having smaller size than neutral atom. This is the concept. Boron and nitrogen, you know left to right the atomic size is decreasing, so boron is more. Oxygen, phosphorus. So here in this case oxygen is belonging to second and phosphorus in the third period. So period down the group means period, in the next period size will definitely increase. That's the reason. So you have to use your brain and all these things. Okay, and you know that higher is the positive charge, successive. If you see the atomic size will be smaller. Okay, because of here proton forces will be more as relative nuclear charge is more. Next is about ionization energy. It is the amount of energy required to remove an electron from isolated gaseous atom to form positive ion. Okay. So here, so if you take the example of sodium basically is in the solid state. Solid we have to change into gas, then only this thing will be possible, because ionization energy is the removal of electron in the gaseous state. Okay. So then the energy required to remove the electron from isolated neutral gaseous atom to form positive ion, that is called ionization energy. You can see from the example, Na gas, when you give the energy, Na gas plus will be found and electron will be out. So the how much energy is required, kilojoule per mole is the unit for that. Okay, that energy. If you want to increase one more electron, let us say in this case not possible Na plus, because it's very difficult to remove the electron from the stable electronic configuration. But if you talk of aluminium you are having 3 valence electron, first can go, second can go, third can go. This way we are saying successive ionization energy. Successive ionization energy IE3 would be greater than IE2 IE1. So all these factors depends on the electronic configuration, shielding effect, that depends on the screening constant, also that depends on the nuclear charge, that depends on the atomic size. All these factors are deciding about the ionization energy. Now here if you see, helium is having the highest ionization energy in the periodic table. See. Okay, because stable configuration and size is the least. And similarly, if you talk of lithium is the least, because left hand side if you go in a period it is increasing. So ionization energy increases in a period. Okay. So now there is some cases are there like nitrogen for oxygen. Oxygen is less, nitrogen is more. Why? Because this is a stable electronic configuration. Nitrogen 1s2, 2s2, 2px1, y1, z1. So this is the stable electronic configuration. These all factors are deciding the overall ionization energy of each and every element. Now generally we can say that ionization energy increases in a period and down the group it decreases. Now this is the trend. In a group ionization energy you can see that it is decreasing, and in a period, in all the periods, atomic the ionization energy is increasing. Atomic number as such is increasing. Okay. Now let us understand about what we have learned. So you can pause the video and try to answer it and check the answer. That would be more better. Okay. So these are the answer. Ionization energy maximum is case of helium, sodium, potassium because sodium is having smaller atomic size, potassium, calcium because calcium is having smaller atomic size, fluorine, Fluorine is having smaller atomic size. Silicon and sulfur, we are having silicon and sulfur. Sulfur is having lesser atomic size, and ignition having maximum ionization energy have Mg2 plus, not Mg, because Mg2 plus is not having any electron, so the ionization energy will be more for Mg2 plus. Please make the correction accordingly. So Mg2 plus will be having more ionization energy as compared to Mg. Okay. Now we are going to take about the electron affinity. Okay, so electron affinity is the amount of energy released. Previously we were talking of ionization energy required. Now this is released when an electron is added to neutral isolated gaseous atom to form negative ion. So if you take the Cl gas, so please remember Cl is not stable as such. Cl2 is there. So Cl2 you have to break, that will become Cl, and then Cl will be converted to gas state. Then only this thing will take place. So Cl plus electron give rise to Cl negative. Sorry for that. So please this also you have to correct it. Cl negative gas. Okay. So then ionization energy units are kilojoule per mole. So similarly, electron affinity, halogens have the highest electron affinity. If you see left to right, if you go, electron affinity is increasing. Similarly, metals are having low electron affinity. Down the group, if you go, metallic character is increasing, so therefore electron affinity value is decreasing. And this is the trend. Normally all these trends depend on the stability of the electron, stability after acquiring one electron, that depends on the atomic size, that depends on the affinity for the stability, that depends on the nuclear, this relative nuclear charge. Okay, so this is the general trend, and you can see chlorine is the having highest electron affinity in the periodic table. Okay, and least is related to alkyl metal here. Fine. Now, so you can see from here also medium is minus 47, and here is fluorine and chlorine. If you see, chlorine is minus 349. So minus word, why it is attached? Because minus means the energy is released. When you are calculating, you need not to bother about minus. You can see the magnitude. So magnitude is maximum for chlorine. So normally we say down the group electron affinity decreases, but this is the chlorine case is opposite. This is a special case, fluorine, chlorine, and second case oxygen, sulfur. So here sulfur is more than oxygen. Otherwise, if you compare chlorine, bromine, that's fine. So down the group the ionization energy decreases. Here also same trend. But in the case of oxygen, sulfur, and fluorine, chlorine, oxygen, fluorine are having small atomic size, and higher repulsions are there when the new incoming electrons are there that is being added into neutral isolated gaseous. They find the repulsion because of small atomic size. That is the reason. Okay, so let us try these questions, and you will be able to, you can pause the video so that you can check out the answers. So you can see that electron affinity is more for chlorine. You can see the table values also, and chlorine, bromine also, chlorine is more, and metal and non-metal, non-metals are more, sulfur and chlorine, chlorine is more, oxygen, sulfur is more, and if you are talking of sulfur, phosphorus, sulfur is more. Okay, so these things are there. Next is electronegativity. It is the tendency of an atom to attract a shared pair. We see that previously we were talking of isolated, neutral, but this is not that. This is shared pair. Shared pair means their bonding is involved. Which bonding? Covalent bonding is involved. Okay, so this is the tendency of an atom to attract the shared pair of electron towards itself. So thereby what will happen? The small delta negative charge will come on one, and small positive delta charge will come on other. Metals are having the least electronegatividity, and non-metals are having maximum electronegatividity. Okay, now this is the trend. Electronegatividity, fluorine is having the maximum electronegatividity in the periodic table, and francium, cesium are having the minimum ionization energy in the periodic table. Means metals are having the least electronegatividity, non-metals are having the maximum electronegatividity. Okay, so these are the values. Down fluorine maximum, francium is the least, and these are the elements which are having values, and these are based on some scale. And see this is a Pauling scale. So the scale is this is the scale. Accordingly, the units has been, the units will not be there. It's a relative measure. Okay, you can see from hydrogen is 2.3, and if you see carbon is 2.5. Means carbon is more electronegative than hydrogen. And if you are talking of fluorine, fluorine is maximum, and oxygen is less than that. Fluorine, chlorine is less. So here trend is same. Down the group it is decreasing. And if you are talking of along the period, this is 0.1 and 1.5 it's increasing. Okay, so along the period it is increasing, and down the group it is decreasing. There is no as such a trend in case of electron affinity. Okay, now so understanding level, you can pause the video and check and write your answers, and finally you can check. So these are the answers. So you might be aware already values are there, we can just match the answers. Okay, next. So if you are able to solve it correctly, if you are able to give correctly answer, if you have understood the concept, that's a great job, because these fundamentals are very important for full-fledged understanding of the inorganic chemistry. We are going to start from Monday onwards. Okay, so let us again repeat the thought: patience, persistence and perspiration, an unbeatable combination for success. Okay, thank you very much.